statistics, we're going to finish up our study of Chapter 5 with Lesson 5.3. We're not going to cover Lessons 5.4 or 5.5. In this lesson, you're going to be finding values. So what we're going to be doing primarily is we're going to take a z-score back to an x value. In order to do that, you're going to have to be able to go backwards in the work that we've done in Lesson 5.2. So this graphic shows you what we did in Lesson 5.2. We started with an x value, you switched it over to a z-score, and then you looked up that z-score in the table to find the probability. So in Lesson 5.2, the ultimate goal was to get to a probability. In this lesson, 5.3, you're going to be given a probability. You're going to have to flip that back to a z-score, and then we find our x value. So it's the complete reverse process. So keep that in mind. If you're going to be given a probability today, that is in the body of the table. So you'll need your book open to page A16 because we're going to be using that table a lot in this lesson. Our first example, we're going to find the z-score that goes with this area right here. And so remember that the z-score gives the area on the left side. And so all you need to do is take your table A16 and find that area in the body of the table. All right, here's a snapshot of what that table looks like. So after you browse through the rows and columns, you're going to be finding 0.3632 right here. So if you trace that back, there's the stem of your z-score. And there's the end, the other hundredths place. So put those together, negative 0.35. There's your z-score. That should make sense. If you look back here, we know z is a negative value. It's on the left side of 0. Okay. This one, they're giving you a percent. So the area that's shaded represents 10.75%. I'm going to write that as a decimal. We know that the table in the back is designated for the areas on the left side. So to get the area on the left side, to get this area right here, we're going to have to take 1 and subtract it. And that is 0.8925. So this is the one that we look up in the table. Again, here's a snapshot of that. Here it is. Trace it back. So our z-score is 1.24. Now you can directly tie z-scores to percentiles. So this represents the 5th percentile. If you scored in the 5th percentile of weight as a baby, that meant 5% of the babies born during that time period weighed what you weighed or less, 95% or heavier. So remember the less part, that is designated to be shaded on the left side of our z-score. So 5, this is the 5th percentile, 5%. It goes to a decimal. This is a probability, so it's an area under the curve. Go to the table, page A16, and find 0.05. So I'm going to give you some time to actually look for that. All right, I think you're stuck. 0.05, there's not an area that's exactly 0.05, but it is in between two of them. you have two areas that are the same distance away from 0.05. The first one is 5 ten-thousandths below, and the second one is 5 ten-thousandths above. The z-score for this one is negative 1.65, and for this one, negative 1.64. So what you're going to do is average them together to get your z-score. So you can add them and divide by 2, or you can just eyeball and come up with the middle. That's what I did. So the process when your area is right in between two values and it's the same distance above or below, you have to average the z-scores together to get that. So we're averaging these to get that final one. Let's go back up here for a second. What if your area was 0.8236? All right, so you're going to be looking for that in your table. Is there an area that's exactly 0.8236? I don't see one, but I see that this one's super close. So what you're going to do, if there's just one that's close and there's not two that are the same distance away, you're just going to use that z-score. So this was the area, this was your z-score. So again, if you find an area and it's not exactly what's in the table, you get as close as you can and use that z-score. The only exception would be, like what we had here, where the two areas were the same distance from the original area. Okay, moving on, we're going to transform a z-score to an x-score. Remember, part of going backwards is this right here, a z-score to an x-score. So we're going to use some algebra skills to do that. All right, we know that from lesson 5.2 and before, a z-score is found by taking x minus the mean dividing by the standard deviation. What I'm going to do is multiply both sides by the standard deviation. And I want to solve this for x. So if I want to solve for x, I'm going to add the mean to the left side. And this, you guys, is the formula you need for finding an x value. Okay, says the speeds of a vehicle along a stretch of highway are normally distributed. So we have the bell curve. The mean is 67 miles an hour. Standard deviation is 4. Find the speeds x corresponding to z-scores of 1.96, negative 2.33, and 0. All right, so I'm just going to use some subscripts here. X of 1.96 equals, remember x is z times the standard deviation plus the mean. So x is our z-score, 1.96 times our standard deviation plus our mean. And then we have x of negative 2.33. So when the z-score is negative, he's under the average, so he's going below 67 miles an hour. In fact, he's going 57.68 miles an hour. When the z-score is 0, that means that you're sitting right there at the mean. So the mean is 67, so that's all you need for that one. All right, so there's the three z-scores. I'm sorry, the three x values for the three z-scores that they gave you. I'm going to stop this video here, and we're going to pick up in the next video with the next example.